Hello, my name is Bhanav and today I'm going to find the Laplace transform of a function f of t which is sine of 2t. So let me flip the camera and we'll get started. Right. So we have to find the Laplace transform of sine of 2t. Now we know that the Laplace transform of f of t, a function f of t, is equal to integral 0 to infinity e power minus st f of t dt, right? And in the case where f of t is sine of 2t, which is the case we're solving, it is integral 0 to infinity e power minus st sine 2t dt. Now in this case we can solve this using integration by parts, where u is equal to sine of 2t and dv is equal to e power minus st dt. So from this we get du is equal to 2 cos 2t dt and v is equal to minus e power minus st divided by s. So from integration by parts, which tells us integral u dv is equal to uv minus integral v du, we get uv, which is minus e power minus st sine of 2t divided by s minus integral v du, which is minus, so that becomes plus e power minus st by s du 2 cos 2t dt. We can consider this now. We can write it as minus e power minus st sine of 2t divided by s plus 2 by s, since they're constants, integral e power minus st cos 2t dt. Now what I'd like to do in this situation is, considering we have to solve this integral using integration by parts again, what we'll do is we'll write it as e power minus st sine of 2t by s plus 2 by s into q, and I'll solve q later. This is equal to the Laplace transform of sine of 2t. So now considering q, so q over here is integral e power minus st cos 2t dt, where u will be cos 2t and dv will be e power minus st dt. So now this du becomes minus 2 sine 2t and v will remain the same as last time, minus e power minus st by s. Let me turn the page, give me a second. Right. So now we use that uv minus integral v du. We know that v is equal to minus e power minus st by s and du is equal to minus 2 sine 2t. So now uv, which will be minus 2 cos 2t by s into e power minus st minus integral v du, minus into minus is plus, so this remains as minus. Integral v du will be e power minus st by s 2 sine 2t. I can write this as minus 2 cos 2t e power minus st by s minus 2 by s integral e power minus st sine 2t dt. Sorry, dt here as well. So now this is the Laplace transform that we have been looking for from the start, isn't it? So what I write here is minus 2 cos 2t e power minus st by s minus 2 by s Laplace transform of sine of 2t. And this is q, since we considered q at the start. So now I have to substitute this back into that. Now, as we know from the previous one, that is minus e power minus st sine of 2t by s plus 2 by s times q, but q we know now is minus 2 by s e power minus st cos 2t and minus 2 by s Laplace transform of sine 2t here, right? So now we have to multiply this 2 by s into the bracket. So what we do is minus e power minus st sine of 2t by s plus minus 4 by s square e power minus st cos 2t minus 4 by s square Laplace transform of sine of 2t. And this is equal to the Laplace transform of sine of 2t. So we take this term to this. So we take this term to this side, and we get 1 plus 4 by s square times the Laplace transform of sine of 2t is equal to minus s e power minus st sine of 2t minus 4 e power minus st cos 2t divided by s squared. So when we take the LCM on this side, when we divide by s square on this side, we get the Laplace transform of sine of 2t as minus s e power minus st sine of 2t minus 4 e power minus st cos 2t by s square plus 4. So now we turn the page and we have to take the limits from 0 to infinity of this term. So we have minus s e power minus st cos of 2t minus 4 e power minus st sine here and cos of 2t divided by s square plus 4. This goes from 0 to infinity. Now, just like last time, if we assume s is greater than 0, then as t tends to infinity, e power minus st would tend to 0. So all the terms involving t at infinity will be 0. And since so if e power minus st is 0, then the term becomes 0. So the lower limit would turn out to be minus times minus e power minus times minus e power minus st. We're taking e power minus e power minus st common. S plus 4 s sin 2t plus 4 cos 2t divided by s square plus 4. But t is 0, so sin 2t becomes 0 and cos 2t becomes 1. So, and e power 0 is 1, so we have minus into minus is plus 4 by s square plus 4. And therefore the Laplace transform of sine of 2t is 4 by s square plus 4. And as usual, I'm the king of math.